NVIDIA's CEO Jensen Huang just made a huge announcement.
All right, so Jensen, I'm going to take it head on. The first word that I saw when I was reading the partnership was expanded. So if it's expanded, explain to me why this is a big deal worth spending some time on for the world's investing populace.
This is a huge deal. The partnership we're announcing today is about revolutionizing one of the most compute-intensive industries in the world, design and engineering. Synopsys is pivoting across their company to transform their software and all the tools that the industry, the world's been using for some 35 years to be GPU accelerated on NVIDIA. They're going to pivot the company to build on top of NVIDIA CUDA, physical AI, as well as Omniverse, so that we could revolutionize all of these tools from EDA to SDA, system design automation, to CAE, to computer-aided drug discovery. This is going to expand the market of computing into the world of design and engineering for the very first time. This partnership is going to be revolutionary for that entire industry, expanding their TAM, expanding the capabilities. You know what's really amazing, Jim? This is really the culmination of everything I showed you when you visited NVIDIA years ago. It's taken this long for us to create the software stack necessary for Synopsys and the rest of the EDA industry and SDA industry in order for them to accelerate the software that they've historically only ran on CPUs. And as a result, we're able to do simulations at a speed and scale unimaginable in the past, so that we could do basically the entire engineering work inside a computer in a digital twin before we have to build it at all. So the type of products we can invent and the quality that we could do and the speed that we could do it at is going to be extraordinary.
Right, Jensen, I think that when you first introduced this to me, you explained to me over and over again, because I was so fascinated by what could happen with a chat GPT with the prompts, was, Jim, that's business to consumer, and it's really, really important. But you better start thinking enterprise. Enterprise is, you were using a number that is 10 times the size of what I was thinking about. Are you still standing by that?
Absolutely. If you look at what we're doing today, if you look, we've been partnering with Synopsys for a very long time. NVIDIA was built on a foundation of design tools from Synopsys and, of course, many other companies like Cadence and Siemens and Dassault. These are very important companies that the entire engineering industry is built on top of. As a result of what we're able to do today, we're able to bring GPU accelerated computing, NVIDIA's CUDA, into the world's industrial sector for the very first time. This is physical AI. This is AI that obeys the laws of physics, that AI that interacts with the physical world. This is extremely complex stuff. It's taken us years to be able to do this. And now, if you look at the world's industrial sector, it's measured in trillions of dollars. So for both NVIDIA and Synopsys and the entire industry, this is a giant expansion of opportunity.
Jensen said this is going to be a huge partnership because they're revolutionizing one of the most compute-intensive industries in the world, design and engineering. They're pivoting the company to build on top of NVIDIA's CUDA, physics, physical AI, and Omniverse to revolutionize tools. This is going to expand the market of computing into the world of design and engineering for the very first time. When most people think about AI, they think business to business consumer. Enterprise AI works completely differently. Enterprise AI runs the actual operations of how companies design and build things. When you're designing a car, you need to simulate crash tests. When you're designing a chip, you need to simulate how electricity flows through billions of transistors. When you're designing a drug, you need to simulate how molecules interact with cells in the human body. All of that simulation work traditionally ran on CPUs, regular computer processors. The problem is CPUs are slow for this kind of work. A simulation that takes weeks on CPUs might need to run hundreds of times as engineers test different designs. That means months or years of development time. GPU acceleration changes everything. They're incredibly good at parallel processing. They can run thousands of calculations at the same time. What took weeks on a CPU can take hours on a GPU. What took months can take days. It makes the software that engineers use to design almost everything. Chips, circuit boards, systems, their tools have been the industry standard for 35 years. Every major tech company uses Synopsys tools. Every chip manufacturer uses them. Every electronics company uses them. So when Jensen says they're pivoting their entire company to run on NVIDIA GPUs, he means they're rebuilding all of that software from the ground up. Every tool, every simulation, every calculation, all optimized for GPU acceleration. Physical AI means the AI understands physics. It knows how materials behave. It knows how heat transfers. It knows how fluids flow. It knows how structures bear weight. The AI simulates reality. It obeys the laws of physics. Digital twins take this even further. You build the entire product inside the computer before you build it in the real world. You test everything virtually. You find every problem. You optimize every detail. Only after everything works perfectly in the simulation do you build the physical version. The speed advantage is massive. If we look at how they currently have to design things, they design something, build a prototype, test it, find problems, redesign, build another prototype, test again. Each cycle can take ages. With digital twins running on GPUs, you can test thousands of designs in the time it used to take to test one. You can simulate things that are impossible to test physically. You can test a chip design under conditions that would destroy a physical chip. You can simulate a drug interaction with millions of different genetic variations. You can model an entire factory before you build a single piece of equipment. EDA means electronic design automation. That's chip design. SDA means system design automation. That's designing entire systems of multiple chips working together. CAE means computer-aided engineering. That's mechanical design, fluid dynamics, structural analysis. Computer-aided drug discovery means simulating molecular interactions to find new medicines. All of these fields require enormous computing power. All of them have been limited by how slow CPUs are. All of them can now run on GPUs and go dramatically faster. The market size difference between consumer and enterprise is enormous. Consumer AI is big, hundreds of billions of people using chatbots and image generators. But enterprise AI is trillions of dollars. Every car company needs this. Every aerospace company needs this. Every pharmaceutical company needs this. Every electronics company needs this. Every manufacturing company needs this. Companies don't have a choice about whether to use these tools. They're not optional. If you're designing a modern chip with billions of transistors, you absolutely must simulate it. You cannot just build it and hope it works. The chips cost millions of dollars to manufacture. You need to know it works before you commit to production. The tools are mission critical. Companies will pay whatever it costs because not having these tools means they cannot do their work. That's why the market is measured in trillions. This is fundamental infrastructure for how the modern world gets built. So that's why the Synopsys partnership is massive. But Jim brought up a concern a lot of people have about AI spending. Let's see how Jensen responds. Quick plug, if parts of this AI stuff feel confusing, we put together a course that explains everything from start to finish. It's built for people who follow this channel and actually want to understand what's going on under the hood of AI. There's a link in the description if you want lifetime access. Back to the video.
If you were here and we didn't have the Synopsys, I would be saying, are you worried that the spend on AI for the data center is now well exceeding the cash flows for several of the key companies, for Oracle and OpenAI, and that perhaps the investment in OpenAI that you've made is a little, maybe should be a little more iffy? Are these the kinds of questions? Is the capex unsustainable for these kinds of, for the hyperscalers? Are these the kinds of questions that are really just part of the horse race and not part of the fourth industrial revolution that you've taught me about?
Most people only see the tip of the iceberg and they see a partial part of the picture, as you know. I think what's going on at the foundation, we're going through a platform shift from classical general purpose computing running on CPUs to a new way of doing computing, accelerated computing running on GPUs. That old way of doing is going to continue to exist, of course, but the world is shifting to this new way of doing computing. The cash flow of the world's hyperscalers are at the core really about supporting this platform shift. With or without agentic AI, with or without chatbots, the world's hyperscalers would have made this platform shift anyhow, because this is a much more efficient way of doing computing. The general purpose computing has really run its course. Moore's law, as you know, is slowing tremendously. And so the world needs a a more powerful, more capable way of doing computing going forward. And so at the foundation, it's that. The second thing to realize is that AI is not just chatbots. Chatbots are incredible. Cognition AI is very important, but AI covers the entire world of physical AI, industrial AI, robotics, sciences, digital biology. AI is going to transform every single industry. This is the part that we've been talking about for a very long time. You and I have been talking about this literally for years. It's just less visible because consumers don't have to use engineering tools that we use from Synopsys and Cadence and others. We don't, our companies use these tools because it's mission critical to us. These industrial applications, these industrial tools where accelerated computing and AI are now in the process of revolutionizing, are foundational to our industries. It's not optional to us. It's mission critical to us. And now for the first time, we're at the tipping point of that, and we're going to revolutionize the industrial software industry with it.
Jim asked if the capex spending on AI for data centers is unsustainable and whether investments in companies like OpenAI should be questioned. The cash flow of the world's hyperscalers is really about supporting this platform shift. The world's hyperscalers would have made this platform shift anyway because this is a much more efficient way of doing computing. So why is Jensen so confident about this spending? The concern is a valid one on the surface. Hyperscalers are spending massive amounts of money building data centers. They're building GPUs, they're building infrastructure. Some companies are spending more than they're generating in cash flow. That looks risky. But the spending is about a fundamental shift in how computing works. For decades, computing has been done on CPUs. That model worked when software was simple and data was small. But that world is ending. Moore's law is the observation that the number of transistors on a chip doubles every 2 years, making computers faster and cheaper over time. Moore's law is the observation that the number of transistors on a chip doubles every 2 years, making computers faster and cheaper over time. That pattern held, but physics is catching up. You can only make transistors so small before quantum effects break them. You can only run electricity through silicon so fast before it melts. Moore's law is slowing down. Every year, CPUs get a little faster, software gets a little more capable, but when Moore's law slows, that progress stops. If CPUs aren't getting much faster and your computing needs keep growing, you have a problem. Accelerated computing solves this problem. Instead of using one general purpose processor that does everything slowly, you use specialized processors that do specific tasks very fast. GPUs were designed for graphics, but it turns out the kind of math required for graphics is also required for AI simulation, data processing, and many other tasks. A GPU could do thousands of calculations at the same time. A CPU does calculations one after another. Hyperscalers are companies like Amazon, Google, Microsoft, and Meta. They run massive data centers that power cloud computing. Every company in the world increasingly runs on cloud infrastructure. Emails, file storage, databases, analytics, machine learning, all of it runs on hyperscaler data centers. These hyperscalers have a choice. They can keep buying CPUs and watch their computing efficiency stagnate, or they can shift to GPUs and get dramatically more computing power per dollar and per watt of electricity. The platform shift means they're choosing GPUs. They're rebuilding their infrastructure. They're rewriting their software. They're training their engineers. This is a multi-year transition that costs enormous amounts of money, but the alternative is worse. The alternative is becoming obsolete. As Jensen said, this shift would happen even without ChatGPT. Even without generative AI, the hyperscalers needed more efficient computing. GPU acceleration provides that efficiency. So they're making this shift because they have to, not because chatbots are popular. If your factory can predict machine failures, you avoid unplanned downtime. That costs millions of dollars per hour. If your logistics systems optimize routes, you can save millions in fuel costs. If your drug discovery processes uses AI simulation, you might develop medicines years faster. Companies must have these capabilities to compete. If your competitor is using AI to optimize their operations and you're not, they'll beat you on cost, speed, and quality. You can't choose to opt out of this transition. The capex concern misses the bigger picture. Yes, companies are spending enormous amounts of money, but they're not gambling on whether it will be popular. They're investing in the fundamental infrastructure they need to remain competitive. That's why the spending is sustainable. All of these benefits directly impact the bottom line. The spending pays for itself. One of our clients started with 0 audience. Now they're doing $100,000 months thanks to YouTube. And they're not alone. We've helped 3 businesses hit that level just by growing them a YouTube channel. Want to see how this could work for your business? Book a call with me below.